altogether. Pretty amazing. But so there's a lot of birds in that area, like the islands of the Indian Ocean, the Australian and New Zealand subantarctics that I'm not really gonna I can speak to definitely, but I'm gonna talk mostly from my experience, and that's mostly again in southern South America, the breeding colonies of albatross there, the particular assemblage of albatross species there, while trying to get a worldview also. So if you have questions about things, birds I don't talk about or cover, let's just get to it in the end and afterwards. So why albatross? They, for me, are just an incredible species for a lot of reasons. First off, they capture the imagination in ways that not a lot of other birds do. For instance, I think that on the daily, probably a lot of people see like house finches, but a lot of people don't know what a house finch is. If you said like, what's a finch look like? They might have an idea. But if you say albatross, a lot of people know the word albatross, despite the fact that almost no one sees albatross in their life. So I think things like this speak to just the cultural importance of them. They live out at sea, far away from land, spending some of them years and years before they ever touch land again. So that's just a really alien environment to us. And they've captured the imagination of sailors, of poets, of authors for ages. Coleridge's Rime of the Ancient Mariner, it's a beautiful poem. If you haven't read it, talks about sailors in the Southern Ocean trapped in the ice, and albatross leads them out. And then one of the sailors then kills that albatross. It's the albatross around their neck that follows them, giving them bad luck. No wind. Uh, it's just a horrible time after that. So it just speaks to people who have been talking about albatross for a very, very long time. And even in more modern times, this is a great song. I'm sure some of you know it. But I would posit that no one in Fleetwood Mac has probably seen an albatross. So just in a way that they capture imagination in a way that's beyond a lot of people's experience. Robert Cushman Murphy, who's the Murphy's petrel is named after, spent a lot of time out at sea describing birds. And in Logbook for Grace, which is a book he wrote for his wife, he wrote this quote, after seeing an albatross, that he now belongs to a higher cult of mortals, which I think is just, it's a really fun way to just experience how touching and how impactful seeing these birds can be. And so why is that? Why do they capture the imagination so much? First off, they're huge. I mean, to simplify it, they're gigantic birds. The great albatross, the royals, and the wanderer complex are all have some of the longest wingspans in the world. So you're talking like over 11 feet, like 11 and a half feet from tip to tip, and some of them weighing in at like 28 pounds and higher for some of the fledglings. There was one fledgling that was recorded at 35 pounds. You know, they feed their young incredibly well. They can take years and years to mature. I mean, some of the larger ones, you're talking like 7 to 10 years. So they're very long-lived birds. We've recorded ones that are still breeding in their 70s and, you know, record them over 80 years old. So some of the longest living birds on the planet, them and the parrots, and just the size, their mystique as far as they live out in a world that's completely alien to us. And I think some of those things just kind of capture imagination in ways that many other birds don't. And this is reflected in their name. I'm really into etymology, like why birds or why anything has the name it has and what's the history behind it. So the family is named after, you know, Diomedes, the hero of Troy. And when he died, his friends all turned into seabirds, into the albatross. And hence the name of the family and for the albatross, and then the genus for the great albatross is in that honor, is named after him. If you look at some of the other genera, you have the cities and the light mantle albatross and the phobetria, and translates roughly to the soothsayers, because there were all these stories of these birds that are living far, far away from land. And when they see them, they're bringing secrets of the sea, of the world, out to the sailors. And then some of the smaller albatross, the most diverse genus, the thassalarks, that roughly translates to the governors of the sea, the ones that command the ocean, command the wind. And these are really reverent names, and I really enjoyed those names, but there's also all kinds of other names. Some of you have maybe been to the subantarctics. I've heard the colloquial name of mollymock. Mollymock was originally a name for the fulmars, which means a foolish gull or a foul gull, you know, where fulmar originally comes from. And that was attributed to some of the seabirds down when folks got there as well. So again, not the best name, but a lot of the other names are really reverent and really mystical. When we talk about the taxonomy of these birds, the Procellformes, those are the storm birds, is the etymology of that word. They're related to the other tube noses, the plated bill birds that live out at sea. There's a lot of common characteristic between the Procellformes. There's 4 genera in the same family and about 20 species. Now, some of you probably noticed that birds like the wandering albatross are no more. The shy albatross is no more. We're finding a lot more through research, through genetics, that these species complexes that used to hold all these different subspecies are in fact have enough delineation to be their own species. So no more wandering albatross, which makes me really sad. I really wish they would have kind of kept that name. But now we have the snowy albatross, the Tristan, the Antipodean, and the Amsterdam, and all these other ones. So we have more biodiversity as we find out more about these birds. So one thing that I want to point out on this map is you see they occupy the world's oceans, not so much in the tropics. These are birds that like a lot of wind, and there's just a little less wind in the tropics. They like cold water in general, not exclusively, but there's a lot more productive there. But you'll notice they're curiously absent from the North Atlantic Ocean. They haven't established breeding populations there. Every now and then, albatross will make their way into the North Atlantic. I think it was earlier, I can't remember if it was earlier this year or late last year, off around the UK, there was a great albatross spotted. I believe it was a snowy albatross, a wanderer type, which is pretty amazing. And then there's a yellow-nosed albatross coming off the coast of North Carolina every now and then. And then famously black-browed albatross, sometimes Bahamas, Florida, and then up in the UK, one's been returning for a few years. So when they make it, they do make it across, but it's when they make it across, they typically stay. And sighting an animal that lives most of its life in the open ocean is obviously really, really difficult. Animals that live out in the pelagic zone, far away from land. So we're talking about what makes an albatross. There's a few characteristics that bring them together, and these are characteristics that we see in most of the Procellformes and the seabirds. And so you're typically looking at white and black, really cold toned in general. Not a lot of different colors in the seabirds, not really super useful for them. A lot of them are counter shaded, being black on the top and lighter below. That's really advantageous to a lot of marine creatures. You can think of that in marine mammals as well, like orca and whatnot. If you're a predator looking down, you can see a black bird blending in with a dark ocean. If you're prey looking up, you see a white belly blending in with the sky. So it's really advantageous. It's kind of counter shading. They typically have high aspect ratio wings, long and narrow, with a short tail that's used just as a rudder. The bill typically is stout, hooked, and covered with plates. These are very ancient birds taxonomically. So they're later on in a lot of lineages, you have fused plates that make the bill, but these still have these plated bills that are really beautiful and really gorgeous. A lot of them have different colors on the different plates, and that's some of the most colorful parts of the birds. They tend to be pretty big and with fairly thick necks and kind of have an overall similar body plan with kind of inefficient legs. Legs that are set very inefficient for land usage. They're perfectly adapted for marine, but webbed feet, short legs, set far apart on the side. So really gangly on land, really inefficient, but at sea, they're perfectly adapted. And they're perfectly adapted for the pelagic zone. Now, pelagic, as many of you know, is the open ocean out in the main, and that's where these birds thrive. They really like to be in areas with high winds, and that's one reason we see so much diversity in the Southern Ocean, particularly. When I say the Southern Ocean, officially 60 south, 60 in poleward of latitude 60 south. But the area where, I'll get to this a bit later, where there's a lot of cold water and a lot of wind that's unobstructed by land. If you look at Antarctica, you can see there's nothing but ocean surrounding Antarctica. It's open ocean. And so winds and currents can just circle around and circle around endlessly with no obstruction. So you get some of the windiest seas on the planet and some of the biggest waves on the planet. And this is exactly what a lot of the albatross want. And that's why we see so much diversity in the Southern Ocean. So they can take long foraging trips, being long-lived birds, taking a lot of parental care. They can stay away from the nest for quite a long time before returning on foraging trips. And some of them, again, like I was saying, don't return to land at all until they're ready to breed. And sometimes they only breed, most of the time, the larger albatross only breed every other year, for instance. So talking about how they live in this environment. Again, this environment's so different from us. Part of it, of what we're familiar with and what we live in. So they really do like it windy. If you see an albatross on a calm day, it's great for viewing. They're sitting on these glassy seas, which is beautiful, but ultimately that's a sad albatross. They would like to be flying. They would like to be having lots of wind. And a lot of times when you see them, they aren't flapping so much. They're doing what's called dynamic soaring. So I'm gonna play a video. We'll see if it works, and I'll try to talk through it. But this is a video of dynamic soaring. This is a great albatross. And as it's going into the wind, it's going up, getting lift, and then higher altitude and descending on this lured descent. I'm gonna not talk to let this video buffer and play. So basically what I was hoping to show in that video is this kind of movement where you see these birds staying nice and low, and then getting a lot of lift from those long glider-like wings, making an ascent where they're slowing down, but they can change direction. And then when they're losing, they don't stall, but they use that downward momentum to pick up speed again, and they kind of repeat this process over and over and over. And so they can do this for days and days with virtually no effort. They've done studies of these birds at rest versus like on the nests versus doing this dynamic soaring, and it's less energy intensive for these birds to do this dynamic soaring than it is for them to adjust on the nest and rest on land, which is pretty wild for us to think about. They're making just small little movements of their tail typically as rudders to do this kind of positioning, to do this kind of movement. And they're perfectly adapted for it. They have tendons in their wings that lock their wings tight. And again, this high aspect ratio is really well suited for a pelagic environment. You're used to this with a lot of the other procilliformes, the seabirds. You think of and some of the other seabirds like the gannets, the boobies, for instance, the frigate birds, really long, really thin wings. And in contrast to something like, a sepiter, kind of a forest hawk that's going to have broad wings, nice and short, or a falcon that's made for really high intensity, really quick flight. So just different wing types for different usages. And just to kind of draw this together, you see the same kind of aspect ratio in things that we do as well. So I never get tired of watching videos of albatross soaring, so I might have a few in here, but this is quarter speed. This was earlier this year down in the Southern Ocean. I took this video, and for me, some of the things I'm trying to get across is notice how that bird's not flapping at all. It's a huge lumbering bird, like I said, 11.5-foot wingspan there, and that's a very old bird right there. That's a very old snowy albatross. I'm not really going to get into the ID, like how to ID these birds. If you want to talk about it afterwards, I'm more than happy to. But I really like the dynamics. You probably noticed that bird was nice and low to the water. So this is an effect called wing and ground effect. Some of you who do aviation might know this already. But when your altitude is about half your wingspan, it creates a bit of an air pocket, or an air cushion, sorry. And with that air cushion, you get a little bit of lift. So when you're out birding, especially when people are first out pelagic birding out at sea, you say, look for the birds, and they're looking up, because that's kind of what we're used to a lot of times with flighted bird, with songbirds and passerines. But seabirds, you're often looking down because they're right at the water's surface. Sometimes they'll wheel up, and certain birds wheel up more than others, but a lot of the albatross, you're looking low, and it is really, to watch a like 28-pound, 11-foot wingspan albatross just lumber through. I can show you videos, I can talk about it, but it's not going to come across. It is really something to behold. It's really amazing and incredible. But these same things don't make them that good on land. So this is a Royal Albatross landing, and that albatross is okay, didn't get hurt, but they're really not well set out for land. So all these adaptations for flight don't necessarily translate out to land. So when they're out at sea, what are they up to? And a lot of them are searching for food. They're off getting snacks, and they're just always out hunting. And how do they do that? So the ocean looks pretty uniform to you and I. You could take a picture of the open ocean and really probably tell most people that you're anywhere in the world, and it'd be believable because it looks like a landscape that we can't tell anything apart. But the marine creatures can. So if we look, for instance, at the bathymetry, of the North Atlantic, you can see there's you can see where the mid-Atlantic ridge is, you can see where the continental shelf is, you can see where seamounts are, and all this is differences in the ocean that some of these creatures are able to pick up on. For instance, these different depths and the way the currents work with them inspired different interactions of phytoplankton. So you'll have different chlorophyll blooms. For instance, this is a kind of just animated graphic of seasonal change throughout years. And what I'm just hoping to show you here is that as the temperature changes, you can see different parts of the ocean are getting a lot more productive with a lot more green. If you notice, those greens are concentrated towards our poleward. So again, cold water is more productive, and that's you're used to, majority of the albatross diversity is associated with cold water. The area that I'm mostly have experience with in the Southern Ocean is this area right here. You can see Tierra del Fuego, southern tip of South America, and the Antarctic Peninsula. And this is a sea surface temperature map. And what I'm hoping to show you here is that very clear delineation. You see right there, we call that the polar front. Now, when I talked earlier about what defines the Southern Ocean, latitude 60 south and poleward, and that's great geographically, but really what defines it biologically is this. This is the polar front that the Antarctic circumpolar current moves around. So with this, you have a clear biological delineation motivated from the water temperatures and the productivity inside of it. And so you see a lot of delineations between that. There's lots of species that you only see on on one side that you wouldn't see on the other, and lots of other small differences too. This is a dramatic difference. Like when we're sailing through here, we notice the temperature go from like 6 Celsius to like 0.3 or minus 0.1 or something like that. So it is, and that's a humongous difference for the ocean. And so we talked about the temperatures, we talked about the bathymetry, we talked about the productivity, and how are the birds picking up on this? So they're doing it by smell. And this is something that's birds have a lot of different senses they're utilizing, but smell in seabirds is of critical importance. For instance, they did this study on Scopoli shearwater, a new species now, thankfully, that used to be a subspecies of Cory shearwater. But they blinded different senses and kind of saw how these birds reacted. And these birds, once they blinded their sense of smell, they did incredibly poorly. They looked very lost until they got within sight of land. They really didn't have much to go off of and couldn't really navigate that well. Well, so this just kind of all points to the importance of smell. We can think of it as a smell map of the whole entire ocean. Different types, different points of the year, there's going to be productivity in a certain place that's not going to be in another place. So they can follow that productivity all through the smell, mostly from phytoplankton blooms. So if you think about the kind of food webs, we start with small planktonic things, phytoplankton is being eaten by zooplanktons, and then you start to get some of the predators that go from there. And you just go up and up and up until you get to, the largest animals on the planet, the whales that are feeding off all these other things, and every predator in between too. And so that's talking about what they're doing when they're out there, they're feeding. Now, many seabirds feed on just kind of what they can get a hold of on the surface. A lot of it is crustaceans, fish, and squid. And albatross really loves squid, particularly. But they're picking things off the surface that, again, they're following these phytoplankton booms. And this is from Cornell's Birds of the World. I just thought this was interesting. It talks about how they feed, but on the very bottom, they say they do not dive for prey. Well, I'm going to show you a video. This is on back of the Humboldt penguin, or sorry, Magellanic penguin. And those large birds you see at the surface and kind of meandering down, those are albatross diving for prey. So I bring this up because there's still a lot we don't know, especially for birds that live so far out. This is from that study that came out on albatross diving. And this is black-browed albatross that we're seeing diving for a minute at a time and down to 60 feet. So kind of wobbling down to 60 feet. And this is to a bird, for birds that, the US's leading authority for ornithology says don't dive for their prey. So the only reason I'm bringing this up is because there's still a lot we're learning. There's still a lot of emergent science, and bring up another one that I think is pretty interesting. They were putting all these trackers on birds. As we get miniaturization and technology, we can just really learn a lot more. And these being big birds, they can really hold a lot of equipment. We're noticing at particularly really dark nights on full moons, we would see this peak in activity, not in the air, but of albatross like moving their feet a lot, moving in circles. And, through a lot of observation, things like that, and extrapolation found that these birds are using bioluminescence as a lure, because as things glow, things come to eat them. And so if you're disturbing bioluminescent plankton, it's glowing, and then you have other plankton coming, then squid especially really love to hunt bioluminescent creatures. And so we have tool use from the albatross, which is just really interesting. So being out at sea, they're obviously in a marine environment, a saltwater environment, and they have adaptations for that too. Seabirds with their plated bill, this is a black-browed albatross, have narrow horns. This is where the word tube nose comes from, where the common name for the family Procselliformes is, the tube noses. And what the function of that is, they have these supraorbital glands called salt glands oftentimes, where there's a lot of salt exchange that happens from their blood to those glands, and then it filters out, goes through the narrow horns, and kind of drips down these little channels, which is amazing adaptation for seabirds. They're able to filter out amazing amounts of salt. Gulls do this as well. So you see this in most all marine birds that live in saltwater environments. But it's also kind of annoying for photographers because they almost look like they have running noses. So you have these like little droplets oftentimes, but that's fine. That's part of their life. But so these are all adaptations to live out at sea, being able to smell incredibly well, being able to filter salt, and again, they're preferred prey species as well. And talking about them being ocean wanderers, I often hear that poetically because they do amazing amounts of movements. They stay near the breeding colonies for foraging trips, like in this gray-headed albatross diagrams I have here. But the rest of the time, they're out at sea for thousands of miles. And again, in non-breeding times, they can stay out for years at a time. There's no reason to come to land. Land is really dangerous. Land is where they're not as well adapted for. So oftentimes when I'm talking about seabirds for folks, it's really hard to wrap your head around that, like, they're not going from point A to B. They're where they want to be. We're in their environment. We're in the open ocean. Talking about using different trackers on them. This is a northern royal albatross right here. We usually, for a lot of devices, like 3% weight is the limit. So you can imagine 3% weight on a hummingbird, that's almost nothing. But 3% weight on a 28-pound bird, you can fit a lot more on. And because of that, we have a lot of really good tracking data. And plus, seabirds are really fidelitous to their breeding sites, almost to a fault in some conservation efforts, that they're going to come back to the same places year after year after year after year and generation after generation. So retrieving things is really great. I mean, you can look at this as opposition to like a swift. Still, chimney swifts we're not really able to track because if we disturb their nesting site, they're just going to go somewhere else and you're never going to get your equipment back, and other factors. But for instance, this is the British Antarctic Survey. Put this tracker on a gray-headed albatross, and just to put a visual to where they're going. This is over a year's time. You can see primarily breeding in South Georgia Island in that upper left, and then taking foraging trips all around to different productive parts of the ocean, but also just kind of transiting. So circling the whole entire globe, going around the world in search of food in an annual cycle. It's really amazing stuff. And these kind of trackers are allowing us a lot more insight into the lives of these birds. This is just a bunch of different wandering or snowy albatrosses that were tracked, and we were particularly trying to note how much they're interacting with fisheries, because their interaction with long-lining fisheries was the leading reason for their mortality. I'll get into more of that in just a minute. But with these tracking technologies, being the fidelity to their site, being they have so much fidelity to their sites and are so easy to retrieve information from and being larger birds, we can learn a whole lot about them, which really, really helps for their conservation. So when they're on land, that's when they're doing their nesting and doing their breeding. And so you see a lot of commonality within pelagic birds, within seabirds. They have high site fidelity. I mean, in a little tangent, but snow petrels, another bird that breeds in the mountains of Antarctica, they've carbon dated some of those sites to see continued usage for 34,000 years of the exact same sites, just to speak to how fidelitous these birds are to their sites, for instance. So this is a picture from the Falkland Islands that I took earlier this year. But colonial breeders really close together. You're not going to see like a nest hidden here, a nest hidden here. They are in large aggregations, and this is true for almost all seabirds. You see penguins in there too. Those are southern rockhopper penguins. They oftentimes nest alongside for a bit of protection from the albatross, but they have their own kind of arguments as well. So This is these are some light-mantled albatross on South Georgia Islands. It's earlier this year, and this is just them doing pair flights. And you've probably seen this if you've ever watched terns during breeding season. Sometimes gulls do this. I really love it. These kind of tandem flights where they're flying alongside each other. This is just part of courtship. Albatross are really known for just a lot of their courtship rituals. And let's see here. I have a little bit of freezing on my screen here, but let's see if it keeps moving or not. But talking about the courtship rituals they do, these pair flights, that's one of them. You'll see them do a lot of bill jousting, which is really fun to watch, kind of clacking their bills together. And then also doing a lot of vocalizations as well, these kind of trumpeting calls, and they're really fun to watch. That's one nice thing about a lot of seabirds is they're fairly what's called like biologically naive. And what we mean by that is they tolerate people. They haven't had a lot of experience with land mammals versus ourselves, so it makes them very vulnerable. But in addition to that, it also does make them very easy to watch. So let me see real quick, because I'm having a bit of trouble here with my my presentation. Could someone just share in what you're seeing right now?
It looks like we're seeing the end of the pair flight video.
Great. Okay. So I think my thing just crashed. So what I'm going to do is restart it, and it's just going to take a second to do that. And so let me just get this back up and running, and we'll be right back on track shortly. Thanks for working with me here. I just apparently Zoom couldn't take the amount of albatross just floating around there. But let's see here. Let's get it back and going. All right. And I think we should be good. Do you see an albatross again?
Not yet.
Not yet. Okay, great. Oh, it helps if I hit this button right there. Okay. All right. Let me just get us to the right slide.
Looks good.
Okay, good. Again, thanks for working with me. I guarantee at this point in your lives, you've seen enough Zoom presentations to know that there's going to be technical difficulties. That's just how life is now. All right, so let's see if we can get here. Do we see two beautiful birds bill jousting?
Yes.
Beautiful. Okay, so again, talking about their courtship rituals. And let's see here. And here's one of them. So those are waved albatross in the Galapagos, and I just wanted to show you a video of like what this kind of looked like. It's pretty adorable. And one thing that I really want to emphasize, and these are white-mantleds in South Georgia, is these birds mate for life. They are fidelitous to a partner if that partner returns. If it doesn't, they'll find another partner, but they stay mated for life as best they can, like many seabirds do. And these birds could have been together for 40 years, and they're just seeing each other for the first time, since they bred last, which could have been 2 years ago. So for me, like watching these rituals is just it's kind of heartwarming, not trying to anthropomorphize too much, but just imagining, seeing someone or seeing a loved one after that long, I think is pretty wonderful. And seeing these rituals and these connections is really pretty too. This is some allopreening of black-billed albatross, kind of same thing. So anyway, this kind of courtship rituals. After the courtship, they mate, they trade out duties. One goes out to sea to feed, the other comes back, and then eventually the chick hatches and they feed the chick. And they really benefit from this biparental care, really long lived. It can take up to a year for some of these chicks to go from, from establishing nesting to fledging. So hence the every other year breeding cycle for a lot of the larger albatross. They put a lot of work into their chicks. Again, this is a characteristic of seabirds, having one, maybe two chicks, putting a lot of parental care in, and then seeing a long-lived bird after that. And they're really adorable too, just covered in this downy, these downy feathers, not having waterproofing and whatnot, but really cute birds. And they just sit on the nest and get fatter and fatter and fatter. And a lot of the young birds are actually heavier than the adults. But just to give you a bit of an idea of how long this takes, again, they have months of incubation, months before they fledge, and then months before they're mature. And these are long-lived birds. This is a gray-headed albatross, just some of the ages. And just circle one there, 60 years old. And we have an idea of how old many of these birds live, but we don't really know. And I know some of you are familiar with this bird right here. This is Wisdom. Last year, this is a licensed albatross out of Midway Atoll off Hawaii, and currently 74 years old and is still actively breeding. So how many chicks has she raised? She's returned to the same spot year after year. And so just kind of pushing the boundaries of what we understand avian life to be able to do, to still have offspring at that age and just to live that long. And that's, again, if they can survive. It's not always easy. There's all these natural causes or environmental factors, that lead to albatross death. But there's also anthropogenic ones, like ones that are from our hand and our influence. And those are the ones I kind of want to focus on just for a minute. First off, when we think about oceans, it's important to think of them as a global system. This is, I bring up this image because this is a warm water lens from 2014 to 16 in the North Pacific, particularly the Gulf of Alaska. It hit really hard. It was called the blob. It was up to 10 degrees Fahrenheit warmer in some place, massive seabird die-offs, many colonies have not recovered. And all this water is moving throughout the whole entire world's oceans. And to put that in context for the Southern Ocean is warming faster than anywhere else because the amount of wind that happens there, there's upwelling that happens. You have the surface water getting blown by wind, and then water from the bottom comes up. So you see a lot of absorption in the Southern Ocean, and we've had less and less ice over the years. And just to kind of talk about how that affects the global systems, and particularly the food production, is you have sea ice, you have frozen ocean. Antarctica historically would double in size in the wintertime from sea ice. All that has algae on the bottom, and that's incredibly important for krill. When that breaks up, all that algae feeds the system, the whole ecological food web down there. Krill being a keystone species, krill is incredibly important for everything down in the Antarctic, and then that gives life to higher and higher things on the trophic scale, including the albatross, including the whales and whatnot. So warmer waters are less productive, and that's in the dynamics. And we're kind of in this feedback loop where there's less ice, so more ocean is being absorbed, less of it's being reflected back. So it's in particularly a feedback loop that's particularly destructive down in the Southern Ocean, but is affecting the water all around the world. I mean, just to give you a bit of an idea, like water from Greenland will come to Antarctica. It takes about 600 years, but it does get there. So many things that are happening today are going to live way, way past us, especially when it comes to the world's oceans. So we've seen huge declines in a lot of the albatross. Some are critically endangered. Many are, at least all of them, are on some level of concern. This is Bird Island in South Georgia, on the northwest tip of South Georgia. This is from the British Antarctic Survey that have been monitoring gray-headed albatross. And we've seen pretty, I would say, massive reductions. And this information is a little dated. It's kind of continued in this trend. But we've seen, just in those years, that 10-year period, right? 10-year period, we've had a loss of almost half the colony of the gray heads and significant losses for the others. Another threat is interaction with fisheries. So obviously fishers don't want to catch seabirds. They don't want that mortality event to happen at all, but especially the long line, and it can really happen. As the hooks are baited, as they go down, that's usually when the albatross are trying to get the prey off or get the bait off the hook. They get hooked and then they drown. And so this was the leading cause of death for albatross in the Southern Ocean. This interaction with long lining, and long lines particularly for Antarctic toothfish, which you might not have heard of Antarctic toothfish, but have you ever heard of Chilean sea bass? It's the same thing. It's just better marketing. So anyway, just to give you a bit of context for that. Another thing that is particularly harmful, so for the seabirds, the signature that they're going after when they're going for food is dimethyl sulfide, DMS. And this is the smell of the ocean. You've probably smelled it if you've ever been like on a low tide on a rocky beach. But this is the smell that the albatross are seeking. And an unfortunate thing is many plastics, as they break up, get algae attached to them, and then birds end up eating that. And this can accumulate in birds' stomachs. It can cut up their internal organs, and they can't really function anymore. Sometimes they starve, sometimes they die from the cuts. There's this wonderful film called Albatross that's free online that is particularly about the Lason's albatross in Midway Atoll that talks about this, if you want to watch that. But they're eating this plastic because it smells like food, because that DMS, and it's just this incredibly unfortunate happenstance. And as you know, plastic in the ocean is an incredible problem. We're learning more and more about it year by year, but pretty much at this point, almost all seabirds have it inside of them. This is a Lason's albatross feeding their chick. There's some food in there, but there's also plastic because, again, they're interpreting it as food. And so even at a young age, it's coming into these birds. And years ago, we thought it was about 50% of the birds. In the 1980s, it jumped about 80% of the birds had plastic. And we're kind of just approaching 100% year by year. And especially as our detection gets better, as we're learning more and more about these birds. And of course, as there's more plastic in the ocean. Some of you might think this was not horribly long ago. Researchers had this new term just to organize thoughts and research around it, plasticosis. And this is a lot of the definitions of the internal, is what's happening internally in these birds' throats, esophagus, digestive tracts with the plastic, how much that's cutting up and how much that's actually causing trouble, as well as the obvious starvations. So being islands residents, albatross breeding on remote islands, they're not used to mammals at all. And they're definitely not used to generalist mammalian predators. So throughout the years, we've introduced mammals all over the world, and this has caused direct mortality. I think was it like a third of loss of biodiversity is from non-native species, especially introduced to islands. So goats, pigs, cats, and particularly for albatross and seabirds, the rats. So I bet many of you already know this already, but rats are incredibly great at surviving. I mean, and they're really hard to get rid of. If you wanted to get rid of rats in a place, I think it's like you have to it's either 96 or 98% reduction in their population, or they'll just spring back within a year. They can go from 2 to 50 in completely perfect breeding conditions. They can go from 2 to 15,000 in a year. Again, that's in a perfect model that would never happen, but even half of that is incredibly destructive. And the albatross are not ready for this. They will just get eaten alive. Like they will sit on their nest. They're many birds, as you know, is to defend themselves, they just sit still. You can think of this as songbirds and, being hunted by raptors. They'll just sit still. That doesn't work for mammals. The rats will just come in to these biologically naive predators that are albatross that are weighing, up to 30 pounds. So really nutritious for these introduced animals. And they're just eating them alive, literally eating them alive. So it's pretty gruesome. It's pretty horrible. But they've had huge impacts. And all these things are just part of what their conservation makeup is. All of them are on some level of concern. There's no extant albatross that is not of least concern. But because of that, and because of their biology, there are conservation opportunities. So this is one of those albatross that's been attacked by the rats. But we have figured out, to an extent, how to remove rats from a lot of islands. There's a beautiful book called Rat Island that's really well done. Talks about techniques used in New Zealand that were, utilized first in Mexico that have been applied worldwide. For instance, South Georgia Island years ago was declared rat-free. This has caused huge rebounds in many of the populations there. Particularly, some of you might know the flagship species for this is the South Georgia pipit. It used to be almost impossibly a South Georgia pipit. And like last year, for instance, they were very easy to see and very abundant. They've taken a big hit this year. They've been incredibly hard to see for other reasons I'll get to. But these kind of derouting and removing introduced species has been hugely helpful for these island specialists. This is a Lason's albatross on Guadalupe Island. So they had a big problem with cats there, but removing the cats caused huge upticks in the populations again. So what I want to say is there's some things that we can have huge immediate effects on. Removing non-native species from islands is something that like we have been able to do. We've done really great jobs in conservation doing that. Longlining, for instance, now longlining has declined for mortality for seabirds has declined by at least 80%. They're trying more and more to get that even higher to 100%. Obviously, that's the goal. But so this is great. This is ways that fisheries have worked, with researchers and conservationists in order to minimize this mortality. So this is really, really great news. And again, something that is all parties are interested in. So that said, there's some threats that have been around for a long time we've been able to get ahead of, and some are just really kind of blindsiding us. I can't not mention HPAI, H5N1. I'm sure all of you are familiar with it, at least by eggs being more expensive, if nothing else. I could talk a lot about this if you have further questions, but the quick thing that I want to mention for albatross in particular is, yes, albatross have been killed from H5N1. In South Georgia Island, I know I talked to someone who works there just a few days ago, and at least 50 have tested positive there. Many others have died from it, but being scientists, they want to say positive testing. So many young have died, many young have not survived or not made it to adulthood at all. So it is affecting albatross. It's in Antarctica. It's made its from its origins around Europe. This particular strain through the Americas. Huge impacts on South America. Just for numbers, in October, I think we had killed 108 million domestic birds, and then alone, and then wild birds in South America is I think it was like 600,000. The paper just came out with those numbers. But anyway, we can talk more about that if you have more questions. There's also more novel threats too. This was an interesting interaction. This is a giant petrel attacking an albatross as a bowler's albatross on the nest and killing it. And this isn't something we've seen before. Giant petrels are these big, they're very large birds, and they're very fierce. They're mostly scavengers, but they do hunt for themselves all the time. And so they've been seen killing albatross on the nest, and they're very well adapted for it. But this is new behavior. We haven't really seen this before. And some people are positing maybe this is from lack of food, like the primary food sources for these giant petrels is diminishing as the food webs, as everything's affected by the decline of the food web and the depression of the food web. So these are kind of novel threats that are really new to us, and we're not really wonderfully prepared for. And this all kind of adds up that I want to leave you with things that give us hope, because there are things that can affect conservation that we can do a really effective and good job at, and we have done, and we can do, and we should still do, because these birds are resilient, but they are facing so many different threats. And currently, the outlook for a lot of these birds is pretty bleak. We have had conservation success for a lot of these species. I mean, short-tailed albatross, our Steller's albatross, we have seen their populations do quite well through conservation efforts, for instance, Lason's albatross as well. So there is hope for these birds. We've done a lot of good work, and we hopefully will continue to do that. And I think it's worth it. These birds, even though most of us don't really experience them firsthand, I hope you do get to see albatross. If you haven't already, I hope that happens to you some point soon in your life. But so few people get to see them, and yet they're so iconic. They capture our imagination. They're an important part of our culture for anyone who likes birds or anyone who likes wildness in general. So they deserve to live. They deserve a beautiful world. And I really, again, appreciate y'all's attention, especially talking about a bird that so few of us actually get to spend time with and see. So thank you all so much. I really appreciate your attention.